Today I'm gonna talk about how to find the limit for piecewise function. So let's take a look the first example. Fx equals 18 plus x for x is less than or equal to 0 equals 18 minus x for x is greater than 0. So how to evaluate the following limit? We basically have two steps. Okay, the first step, we're gonna draw the x-axis. Okay, and then we're gonna find the breakpoint. We know the breakpoint here is 0 because we have 0 break this function to two pieces, right? So we have breakpoint 0. Okay, where x is less than or equal to 0, we have function 18 plus x. So we can write 18 plus x on the left hand side. Okay, of course it's above this x-axis. And we also can write 18 minus x on the right hand side. Okay, because x is greater than 0, we have 18 minus x. Okay, now second step, we're gonna find the limit when x approaches 0 from left hand side. Okay, left hand side. So we can draw an arrow from left hand side. Okay, draw an arrow, approach 0 from the left hand side. Okay, and now it corresponds, the function is 18 plus x. That means we can plug in the fx is 18 plus x. Now we can plug in 18 plus 0 equals 18. Now let's take a look the limit when fx approaches or when x approaches 0 from the right hand side. So we can draw the arrow from right hand side. It corresponds, the function is 18 minus x. So we can plug in 18 minus x. Okay, then we can plug in 18 minus 0 equals 18. Now, how to evaluate the limit when x approaches 0? We're gonna use the property of left hand limit and right hand limit, because left hand limit equals 18 and the right hand limit equals 18 too. So that two equals each other. That means the limit fx equals 18. Okay, now how about the value when x equals 0? Now we need to go back to the original piecewise function. We need to check which function include x equals 0. Okay, x equals 0 is very clearly, we can see the first function include x equals 0. Okay, because here we have equal sign, right? So we can plug in 0 here. We have 18 plus 0 equals 18. Now let's take a look. The second example, we're gonna follow the same strategy. The first step, we draw the x-axis, and we have the breakpoint, right? -3, because x equals -3, we break this function to two pieces, right? Two pieces. So when x is less than -3, we have x plus 4 on the left hand side because it's less than -3. When x is greater than -3, we have square root of x plus 3. Okay. Now we can evaluate the following limit. So the first limit is x approaches -3 from left hand side. So we can draw the arrow from left hand side, or left arrow. Okay, and it corresponds, the fx is x plus 4. So we just plug in the x plus 4. Okay, and then we plug in -3 here. -3 plus 4 equals 1. Now let's take a look. X approaches through -3 from right hand side. Okay, we're gonna draw the arrow from right hand side. It corresponds, the function is square root of x plus 3. Okay, so we can plug in square root of x plus 3. Now we can plug in. So we have -3 plus 3 equals 0. So here's a 0. Okay, now how about the limit for the fx when x approaches -3? We're gonna follow the property of left hand limit and right hand limit, because left hand limit equals 1 and the right hand limit equals 0. These two doesn't equals each other. That means this guy doesn't exist. Okay, and the last one, f -3. Okay, now we need to check which function that include x equals -3. We're gonna check the first function doesn't include x equals -3. The second one, neither. Okay, so that means doesn't exist because we don't have equal sign. Okay, equal sign to include x equals -3. Okay. Now let's take a look. The third example. Okay, we're gonna follow the same strategy. The first step, we draw the x-axis, and we have breakpoint that is 0, and on the left hand side we have function x squared minus 36 over x plus 6, and on the right hand side we have x squared minus 36 over x minus 6. Okay, now let's take a look. We want to evaluate x approaches -6 fx. Okay, how to evaluate this guy? We're gonna check where is the -6, because -6 is not breakpoint, right? So we can easily find -6 is here, right? -6 is here. It belongs to what? It belongs to this function. Okay, it belongs to this function. So that means what? We can directly plug in this function. Okay, this function. And how to evaluate this limit? As we can see, it belongs to 0/0. Okay, we can easily tell that guy it belongs to 0/0 when you plug in -6 for both numerator and the denominator. We're gonna get 0/0. That is indeterminate form. So how to evaluate indeterminate form? We're gonna using factoring method. Okay, here we can use the formula, the difference of two square. I'm gonna write down the formula here. A square minus b square equals a minus b, a plus b. Okay, so here 36 we can write down as what? We can write down as 6 square, right? 36 can be written down as 6 square. So the b is 6, a is x. That means we can write down as x approaches -6. So we have x minus 6, x plus 6. And for the denominator is x plus 6. So now we can cancel out. After we cancel out, we have, we'll write down here, x approaches -6. We have x minus 6. Okay, now we can plug in. -6 equals -12. Okay, 12. Now let's take a look. The limit fx when x approaches 0. As we know, 0 is a breakpoint. We're gonna use left hand limit and the right hand limit to check this limit. Okay, so the first things we need to find left hand limit. Okay, that means when x approaches 0, from left hand side we have a function that is this guy. So we plug in limit x approaches 0 from the left hand side, that is x squared minus 36 plus over x plus 6, and you can plug in the 0, and we're gonna get -6. Okay, -6. And of course, for the right hand limit, x approaches 0 from right hand side, we're gonna draw the right arrow, right? And it corresponds, the function is here, so we plug in that is x squared minus 36 over x minus 6. Okay, and now you plug in 0. That is 0 minus 36, 0 minus 6. That equals 6. Okay, and we can see the left hand limit is -6. The right hand limit equals 6, positive 6. So these two doesn't equals each other. That means what? That means this guy doesn't exist. Okay, now let's check the last one. The limit of fx when x approaches 6. Okay, and we can tell 6 belongs here, right? Belongs here on the right hand side, and that belongs to function is this guy. So that means we just plug in. We have x squared minus 36 over x minus 6. And again, we can find this guy belongs to 0 over 0 when you plug in x equals 6 here. So that means we can use the factoring method, because here 36 can be written as 6 squared. So we can use the difference of 2 squared. Now we can do it. X approaches 6. That is x minus 6, x plus 6 over x minus 6. We cancel out and plug in the 6 here. We're gonna get 12. Okay, 12. Now let's take a look at the last one. For the last one, we can tell we have 3 limits, right? We're gonna follow the same strategy. Draw the x-axis, and we have breakpoint that is 0, and on the left hand side we have function x over x plus 12, and on the right hand side we have x over x minus 12. Okay, now let's take a look. The first limit when x approaches -12. So the first thing we notice that -12 is not breakpoint. Okay, it's not a breakpoint. Actually, it belongs to here. So the function should be this guy. Okay, should be this guy. So we can write down this guy as x approaches -12, x over x plus 12. Now let's check. When we plug in x equals -12, we find the limit can be written as -12 over 0. That is not indeterminate form, because indeterminate form is 0 over 0. Here is negative over 0. So that means this limit doesn't exist. Okay, because it's divided by 0. Now let's take a look the second limit. For the second limit, we're gonna follow the same strategy. We're gonna calculate the left hand limit. X approaches 0. Left hand limit. How to find the left hand limit? We're gonna draw the left arrow. Draw the right arrow. Okay, draw the arrow from left hand side. Okay, draw the arrow from the left hand side, and corresponding to the function is x over x plus 12. We just plug in it. Okay, so we have x over x plus 12. Okay, and plug in 0, we have 0 over 12 is 0. Now we're going to try the right hand limit. Okay, and for the right hand limit, we draw the arrow from right hand side. Okay, and we can tell the function is this guy. So we have plug in this function x minus negative 12. Okay, x over x minus 12. So we plug in 0 minus 12, that is 0. Okay, so now we have the left hand limit, that is 0, right hand limit, that is 0. That's 2 equals each other. So we can get the limit for fx when x approaches 0, that equals 0. Okay, 0. Now let's take a look. The last one. Limit x approaches 12 fx. As we know, the 12 is not breakpoint, so we have 12 here. It belongs to the function x over x minus 12. We just plug in. Plug in x over x minus 12. And again, when we plug in x equals 12, we find that belongs to 12 over 0. Okay, so that means this limit doesn't exist. Okay,